Well, a very good afternoon once again, ladies and gentlemen, and a very warm welcome back to the Grand Salon for the second fabulous conversation this afternoon. So without further ado, ladies and gentlemen, it gives me great pleasure to reintroduce the fabulous Professor Valentin Troll.
Thank you very much, Robert. It's, as always, a pleasure being here. And today I want to talk a little bit about the good sides of volcanoes. So we looked at all the terrible things volcanoes do, and as so often in reality, things are not black and white, things are not good or bad. And that's the same with volcanoes. Volcanoes have positive sides as well as hazardous sides. And today I'd like to focus on the more positive aspects. So to start off, well, I think volcanoes have a bad reputation, they have a bad press, because they usually end up being reported on when something bad happens or something spectacular happens, and it sparks the imagination in many movies, and we'll come back to movies a little bit later in the presentation. It's the volcano that's the opponent or the bad natural force, and some hero has to struggle against these forces. So the volcano is always put into that corner of being the culprit. And in a way, rightly so, because in many volcanically active areas like Hawaii, like in Italy, we do struggle with that. And I showed images like this before. This is from Indonesia, where things are even more dangerous, where we are dealing with pyroclastic flows, these explosive, glowing avalanches, and they travel with enormous speed. There is almost no escape from those. And this is, of course, images that make it around the world. But volcanoes also provide an enormous amount of resources. And I make a very important point, I think, by saying that our life wouldn't be the same without volcanoes, in a positive and, of course, also in a negative way. And resources, or ecosystem services, as the more modern phrase would be, well, this is about volcanoes and their underlying magma systems. We talked about that, and those are actually the principal agents of redistributing minerals and elements within the Earth. Volcanoes are therefore key features in the understanding of any localized concentration of, for example, metals, minerals, fluids, geothermal fluids, which are crucial for us humans at the surface. And I should stress, and I get this question very often, is there volcanoes in Sweden? And the answer is, of course, there is no volcanoes in Sweden. No active ones is my usual response, because the mineral wealth of Sweden, and maybe some of you have heard about the giant Kiruna mine in the north in Arctic Sweden, which is the #1 iron producer in Europe. It's an old volcano, of course. So, and here often volcanic rocks, they bring or concentrate elements, base metals like iron, for example, but also more sophisticated metals. And this makes a country like Sweden, which used to be volcanic in the geological history, into a very important ore producer. And here's a bunch of my students when we're looking at the mines and looking at old volcanic features down there in some of these large mines in Arctic Sweden. So, and what you get there is not just base metals like iron and copper, you also get gold and silver. Most gold and silver actually comes originally from volcanoes. It's washed out, and you find it eventually in river deposits where you pick up nuggets, but originally it comes from volcano structures, from volcanic mountains. So most metals actually come from these places. And the most important metal, despite our need for critical metals these days, the most important metal is and will be for quite some time iron. Iron is what we need to build any major structures. To reinforce concrete, to build bridges, to build railways, we need iron. So iron will be demanded by society and industry for many decades to come. And nowadays, because of our green technology efforts, we need more and more unusual metals, manganese and cobalt, for example. And right now, most of the cobalt that is mined comes from one place, and that is the Congo. Conditions are not always ideal there, and everybody in the Western world is looking for alternatives. The rock sample in the top left here is actually a specimen from the Canary Islands, from one of the submarine volcanoes. And you see that thick, dark crust on top? That is rich in cobalt and manganese. So this is why a lot of people are starting to think we should actually exploit submarine resources, submarine volcanic resources, because they could be very rich in cobalt and manganese that we need for batteries. So maybe volcanoes can even provide a big boost towards our green technology transition. But moving away from metals, well, we can look at gemstones, and you're all familiar. Crown jewels all over the world are stunning, but what most people don't realize is that what you really need for that, gemstones, like diamonds, they come from volcanoes once more. So there in South Africa, at a place called Kimberley, initial finds of diamonds were made, and there we have a peculiar type of volcanism. It shoots up from deep inside the earth and it brings up carbon, but carbon that was under enormous pressure. And the carbon doesn't have time to adjust, so it stays in this pressurized form, and that is what we look at as diamonds. And this is why diamonds actually burn. If you leave them behind in a burning house, they have a very limited survival chance. The only other way to make such precious is meteorite impacts, as you see in the top right. And they are very, well, seldom and far between, and they don't always hit the right rock, so you cannot quite rely on meteorite impacts in the same way as volcanoes to create diamonds. Another important thing is, of course, tools. Man has worked with all sorts of stone tools prior to metals becoming a thing, and many civilizations, like on Hawaii or in New Zealand, Aboriginal civilization, and in the Canaries as well, where metalworks was not known, they used stone blades, for example. Obsidian is very, very common here, because when obsidian breaks, it actually makes a really, really sharp edge, sharper than most metal scalpels. And this is why some surgeons, I researched on the internet, actually apparently still work with obsidian rather than metal scalpels, because the cut is apparently super clean, because the broken edge of an obsidian is down to 1 atom size, so it's the sharpest cut you could possibly get. And, well, these are of course known for, well, a long time, and in many civilizations here is several specimens of cutting blades made of obsidian from Turkey, 5th millennium BC. There are some other ones from Mexico, from Mayan culture. And all over the world, these rocks were sharpened in order to produce cutting tools. And I came across this the other day. There was a find in Turkey, and apparently this could or was a mirror. And it means that the oldest mirror that we actually know of today comes also from volcanic rock. It's a polished piece of obsidian, which was just about good enough to see yourself in it. Another important, industrially important aspect of volcanic rock is we use pumice very frequently for abrasion material, and we use this on an industrial scale, of course. But I should point out, if you buy cosmetics and you look at the small print, you'll actually come across a lot of volcanic material in cosmetical products as well. So let's see whether I get this to work. So here, for example, it says reviving pumice foot scrub. And here, for example, oops, there we have the reference to the volcanic rocks inside. So here, volcanic pumice, stone, and this is widely used for cosmetical purposes as well. And believe it or not, when you have a toothpaste that is whitening, then most likely there's tiny little volcanic glass shards in there as well, because they remove all the things on abrasion. And when I was young, there was this new fashion coming over from the US, and people were suddenly not wearing dull, plain blue jeans anymore. They had to be stone-washed. And, well, I had no idea back then, but the stone is actually pumice stone. So you put pumice stone into a tumble dryer and you put the jeans in there, and after a while it looks like this. So it's abrading, and this is of course the key feature here. Having said this, I should also point out that white gold porcelain china is also something that comes from volcanoes. You need three main components, and that is quartz, feldspar, and clay, and all of them form from weathering of granitic rocks. Granitic rocks form in the depth, in the bowels of big volcanoes, and if you then put them together at the right proportion and treat them right, with the right moisture, and you burn them right, they make porcelain. And you can glaze that, and the big advantage is you can clean it again and again and again. It's super hygienic. And it is believed to have been instrumental in the population revolution in Europe, because suddenly, well, think about wooden plates, you don't want to eat them forever. So here, there was a clear distinction made in the way we live using porcelain when it came over from China. Another feature that is very important that volcanoes have traditionally produced, less so right now, but that is sulfur. We have mined a lot of sulfur from volcanoes. And, well, the obvious thing we do with sulfur is we make gunpowder. And gunpowder needs charcoal, potassium nitrate, and sulfur. And, well, a lot of the previous conflicts over geological history were, well, fought with sulfur. And Sweden had a period where expansion all over Northern Europe was anticipated and pushed for. And the sulfur for all the gunpowder came from Iceland. So there was real contracts with Iceland, how to mine and how to ship the gunpowder, how to make it to a certain grade of purity. Now, these days, we're actually producing a lot of sulfur as a byproduct of petroleum refineries. And therefore, we don't have to mine natural sulfur anymore. But if we go off fossil fuels in the next decades, we actually will require another source of sulfur again. So this is a weird byproduct of technological developments, and I think we might need to go back and mine volcanic sulfur again. In addition to the use in explosives, well, Nobel, another Swede, obviously he developed dynamite, and this allows the useful exploitation of explosive nature that sulfur creates. And another thing is disinfection. I should point out that sulfur is very good for disinfection, and you can still buy in some parts of the world certain medical products or cosmetical products like the sulfur soaps in China, which are very good for your skin, and apparently they calm your skin and clean it properly. Another aspect I must not forget to mention here when we talk about the positive sides of volcanoes, that is geothermal power. I should point out that Northern Europe, well, there's one country that sticks out when it comes to banana production, and that is Iceland. Iceland actually has the highest banana production in Northern Europe, not because the climate is so good, but because they have geothermal energy, and they supply greenhouses with that. Now, this is something that will take off in a grand scale over the next decades, and it was pioneered actually in New Zealand, but nowadays it's spreading all over the world, and here's a geothermal power plant in Indonesia, for example. And here's the one in Iceland that's currently being pushed up by a volcano. That's the Svartsengi power plant. And the water that is left over from the power plant is poured out into a little depression, into a little valley, and there it makes the Blue Lagoon, and the Blue Lagoon is now one of the major tourist attractions of Iceland and a huge source of revenue. So here's a little chart in the top right, and hopefully you can see this, but most of the geothermal energy is actually used for space heating in Iceland, and another 40% is used for electricity production. And then there is, of course, some use for all sorts of other applications in some places. They even heat the roads with geothermal energy because, well, it can get icy in Iceland. So, and if you go to the Blue Lagoon, then you'll be bombarded with all sorts of, well, cosmetical products that are good for you. And apparently they're really, really popular. For some strange reason, I was talking to a person working there at the Blue Lagoon, and she told me that the products sell particularly well in Asia. I have no idea why that is the case, but the Blue Lagoon mods, they have a lot of silica. Silica dries out your skin. It therefore cleans your skin, and that is very good for certain types of skin, at least. So you can purchase these cosmetical products from Volcanoes in places like Iceland. But thinking about volcano mud or precipitation of mud from volcanic fluids, I should also mention solars, and this is from a trip to Chile a few years ago. This is in the Atacama Desert. It's a very high plateau. It's surrounded by volcanoes. It's very dry there, and there is groundwater that comes to the surface, and it evaporates very swiftly, and it makes these salt lakes. All the white you see there, it's actually not snow, it's salt. And these salts contain a lot of lithium. And lithium is, of course, important, again, for batteries. So these salt lakes in the high volcanic desert of Chile and Bolivia and Argentina, actually, they will likely become a major source of lithium for battery production. And this has already started. Naturally, there's some discussion about what it does to the environment, and there's also some opposing opinions. But increasingly, the mining takes foot, and a lot of the lithium is actually shipped to China and Japan. They're paying huge amounts of money for these kind of products, and therefore I think economy will determine that mining there will actually grow stronger over the coming years. And if we really want to electrify our traffic, we would need a lot more batteries than we currently are able to produce. And for that, given the current technology, we need a lot more lithium. And this is a very easy to quarry source of lithium. So let's move on and talk a little bit about volcanoes and buildings. We've just been to the Canaries. We're just sailing off, and there's a few archaeological sites in the Canaries that are built into volcanic rock. And it's not uncommon. People are digging into soft rock, and some volcanic deposits are very soft. And here, for example, we have this cavernous structure in the north of Gran Canaria, which was used as a grain store by local Aboriginal people. Very close by, there is this cave here. It's also dug into relatively soft volcanic rock. And this cave is called the King's Cave, and it's very spacious. And well, personally, I would still not want to live there, but it is surprisingly good for a cave. And other caves have been converted to restaurants now in the Canaries, so you can go to cave restaurants. And here's an example on the right-hand side, which is very nice and cool on a hot day. Some of you may have had the opportunity to go to Turkey, and Cappadocia is, of course, world famous for the cave dwellings. And again, this is also soft volcanic rock, so this is not a feature unique to the Canaries. It's found all over the world. And you still actually have people in Europe, certainly in the Canaries, living in some of these volcanic caves. And I know that in Central Europe, like in France, people lived well into the 1950s in volcanic caves, and they claimed that the climate was very pleasant inside. It was, well, like a natural cooling system on hot days and the other way around. Now, I should point out, traditionally, we also have looked for high ground in order to feel protected and have a good overview over our surroundings, and volcanic rocks have been very, very helpful here. So a whole series of imposing buildings, from churches to castles, are built on volcanic blocks and necks, meaning volcanic rocks that were prepared out by erosion over millions of years. And here's just a few examples. There is Saint-Michel in France, the Regensburg in Austria, or Edinburgh Castle in Scotland. It's not just a European feature. The largest Buddhist temple in the world sits at the foot of Merapi volcano. It's called Borobudur, and it's built entirely of volcanic rock. And not even of very light volcanic rock, it's built of massive volcanic rock. What an engineering feat. And well, it got so heavy in the middle that it actually started to sag, and the jungle went over it. But then colonials found it, and they started to unearth it, and now it's been reconstructed and you can visit it, built entirely of massive volcanic rock. But looking at architecture and infrastructure made of volcanic rock, we cannot bypass the Romans, of course. They started to actually use volcanic mud and various ground-up volcanic minerals, and they actually built what we know to be the first cement, the pozzolana cement. And that allowed them to stick rocks together. And that was a huge technological advantage, because suddenly you could construct taller buildings. You could, construct the Pantheon. And the Pantheon is still standing, believe it or not, after all these years. So it's quite impressive. And of course, the Colosseum is made from a similar style, using similar technology. So the Romans, being, in a volcanic region, they had plenty of time to experiment, and they came up with these intriguing technological developments. We've just been to the Canaries, and this is a little village church in the village of Arico. And this is also made of, in this case, a red volcanic rock, and you can just about see this. This is a porous volcanic rock, and in most of the Canaries, as well as in South America, people have built large cathedrals and large churches with more and more porous rock higher up in the structure, so that the structure gets lighter and lighter higher up, and that allowed them to build taller churches and structures. This was a trick that was also, of course, used in many parts of the world. This is from central France, Clermont-Ferrand. There, the cathedral of Clermont-Ferrand is also built of volcanic rock. And there, of course, people were very clever, using the heavy bits low down and the fluffier bits of rock higher up. You may have heard that, when they found the first Viking skulls, the Vikings had really bad teeth, it looked like. But it turned out that actually it wasn't the teeth that were so bad, it was that they imported volcanic millstones to grind the grains. And that meant there was a lot of volcanic fragments, little ash fragments in their bread. And so they ate this a lot. And this was a cause of their, abraded teeth. And we still do that in many parts of the world. I know in Mexico, for example, there is still family secrets about where to actually take your rock for your next kind of stone, so that it would not abrade to the same extent, and therefore it would not ruin your teeth. So this is a widespread phenomenon. Nowadays we grind corn differently, but back in the day, volcanic rock with its distinct hardness was very popular for that. And then, of course, we use volcanic stone in all sorts of paving, cladding, and decoration. And we use a lot, and actually that's vast amounts of volcanic stone to supplement concrete. So we use a lot of gravel and aggregates to put it into concrete and also into tarmac. So you use more aggregates per capita than you use metals. So we are all using a lot of this material. And when you think of the houses like here in the Canaries, when you look at the construction of these houses, about 30 to 40% of what you see in that picture in the lower left is actually made of volcanic gravel mixed into concrete. So, and here's a little quarry that does exactly that. That's from Indonesia, from Merapi volcano. And there, people take the volcanic ash deposits because it's already ground up, it's already fine-grained, and they use this in agriculture, but also in construction. And on top of that, they're doing this purposefully disorganized. At first, you kind of go and think, wow, they're digging quite randomly. But then you learn there is a method to this. It is, broadly speaking, perpendicular to the flow direction of any new volcanic eruption, and therefore it would actually slow down a new volcanic eruption. So the quarry is, in a secondary function, also a brake for the next eruption, to make it slower, to create friction for the eruption, and therefore ideally reduce the run-out distance. So, I promised a few words about the use of lapilli and pumice stone, and this is something that was really pioneered here in the Canaries. But we all know volcanic rock is making a very fertile soil. This is used all over the planet. So in France, you get the Cuvée de Volcans, and at Etna, you can get volcano wine, and you can do that in the Canaries, of course, as well. And one issue is that if you have all three components, water, tropical climate, and volcanoes, then you have the lushest environment you could possibly have. And this brings me back to Indonesia again. There you see the rice paddies in the lowlands below Merapi volcano. And this is Merapi volcano on a, well, dry day. And this is Merapi volcano when it rains. There's a lot of water there. And the combination of these factors makes a very lush and very fertile environment. This is why we have so many spices growing there. Indonesia is also known as the Spice Islands. And they all grow, and some products like the Krakatoa pepper try to capitalize on that. I should also make a few kind of statements about coffee. Coffee, believe it or not, is to more than 70% grown on volcanic soil. So when you have a cup of coffee in the morning, you somehow most likely touch some sort of volcano. And coffee consumption is actually very, very high in Northern Europe. There you see the darker colors are the highest coffee consumption per capita. And Scandinavia, where I'm from, well, we drink a lot of coffee, likely because it's so dark, and we have no volcanoes, so we import the flavor, I guess. And then in many parts of the world, we drink tea instead of coffee, and tea is less much grown on volcanic soil. Coffee, however, is to a large degree grown. And this is a few images from Indonesia. This is a coffee plantation, and there you see the coffee beans. This is from East Java. And just a few impressions here. So this is how they look, and then you have to dry the beans, and then you have to roast them, and eventually you get a ground coffee powder. So in addition to coffee, a lot of chocolate is actually grown on volcanic soil as well, less so than coffee, but here's a chocolate plantation again in Indonesia, and it was rather pleasant to actually have the coffee and the chocolate together. And well, this is true all over the world, of course. If you go to Hawaii, for example, there you grow all sorts of fruit on very fertile soil, and it's a little small in the lower image there, but on the Dole plantation there they make an important point, and that is their pineapples wouldn't really grow that juicy and that tasty without the volcano underneath it. So having mentioned this, tea, I said before, is also grown on volcanic soil quite frequently, and this upcoming plant is as well. Does anyone have any idea what this plant would be? Well, this is how it looks when it's small. This is how it looks when it's grown a little bigger. And this is what you do with it. You smoke it. It's tobacco. And tobacco is falling a little out of fashion now. But tobacco was grown here in the Canary Islands. Winston Churchill, for example, he had his cigars from La Palma. And nowadays, we are still using tobacco, but we're using the nicotine as, for example, a pesticide. And this is what the plant originally intended to do with the nicotine. It tried to fend off other creatures eating it. So, and humans started to enjoy nicotine. And nowadays, we're going back to the original idea. And, well, every now and then, of course, I guess if you have something to celebrate, a cigar is probably quite appropriate. And this is not just a feature of the Canaries. You also get this, for example, here on Hawaii. I did try the coconut flavor back then. I wasn't entirely convinced, but it was an experience, let's put it like that. So, yes, here, coconut, that was my guess. So, then we talked a little bit about making wine before, and we've just been to Lanzarote. There we had a very dry climate, very poor agricultural conditions. But after the 1730-36 eruption, local people learned to use volcanic ash to sprinkle on the fields to increase the moisture budget of the soil and to provide nutrients. And it led to a lot of wine being grown there. Now, because the island is rather shallow, there's a lot of wind, so people built little walls to protect the grapes. And this gives rise to this typical Lageria style of growing wine that originates from Lanzarote. So, and there we have entire valleys being cultivated this way. And nowadays, Lanzarote wine is, well, having a second run at fame, and it's actually starting to win prizes again. So there was a bit of a decline over the last 50 years, I understand, but now it seems to come back more strongly. A few words about the Lanzarote 1730-36 eruption. The grey on that little map there was unaffected territories, while the colored areas were covered by lava and pyroclastics. About a quarter of the island was actually covered with volcanic deposits at the time. It was a socioeconomic catastrophe, and it took some time for the island to recover, obviously, and eventually it did do so using this particular technology, and until the 1780s, some 50 years after the eruption, the population of the island had doubled. Now, the grape that is grown is the Malvasia wine, and it grew so famous within a few decades that it was drunk at the Vienna Congress. You still have the old, well, dining menus, and there the Lanzarote wine is listed as a particular speciality. But I got really interested in my research, thinking about everybody says, oh, these particles can hold water. And that's good and well, water is an important ingredient, I get it, but something else was missing, at least for me. So we started to look with the electron scanning microscope into some of these volcanic particles. And what we discovered was this. These little volcanic particles that sit in the soil, in the fields, they're actually teeming with life. There's loads of tiny little microorganisms in there. And I am not so good with microorganisms, so I had to ask some colleagues, and they named all the different little microorganisms that live in there. And the important realization is it's the living soil, the microorganisms that break down the volcanic rock, and they allow the plants to take up these nutrients. So the rock itself and the plants itself is not as good as the rock and the transmitter of microorganisms that produces digestible nutrients for the plants. So if you are into agriculture and gardening, the important thing, of course, is phosphorus, nitrate, potassium, etc. And the rocks can provide that. But we also have living soil. We have the activity of microorganisms, and they lock CO2. And this led a lot of people to believe that not only is it good for the plants, the living creatures, the microorganisms, would also, in theory at least, sequester CO2 from the atmosphere into the soil. So people have started to research this over the last few years. And not only can we produce very fertile, reasonably fertile fields in a very dry environment. Here, the only really hardcore scientific graph I'm going to show today. This is the projections of how much CO2 we could lock in soil if we were to systematically spread volcanic ash over fields in many countries. And I marked in red here Spain, and it says that we could potentially produce close to 10% of the Paris Agreement commitments of CO2 sequestration, CO2 removal, by putting it into volcanic particles in soil. So this is a very inexpensive way of dealing with some of our climate issues, and I think we have more to expect from this method in the future. So, but a few words at the end about some other aspects. And of course, partly this is what we are doing. Volcanoes are also good for tourism, for geotourism. It goes back many, many hundreds of years. People have used volcanoes as landmarks. Darwin said volcano landscapes are the most fascinating and the most beautiful in the world. And here's an old map from Iceland. And well, there was a bit of a speculative element there. You can see some of these creatures at the bottom. They are morally not quite real. But when you look at some of the descriptions and some of the features, the volcanoes and the ridges of mountains, they have been used as landmarks, and that allowed navigation. Of course, these days we still have volcano tourism. People go very close to volcanoes, sometimes with negative consequences. Sometimes we have, well, eruptions like the White Island disaster in New Zealand. But in general, you can get pretty close to volcanoes these days. And in the top right, that's my nephew, when I took him to La Palma, to the visitor center there a few years ago. And you can see his grin. He was very happy about it, of course. So, volcano tourism can be very, very important for some places. For some countries, certainly, if you're a little country like Iceland, low population, not a lot of revenue, a volcano can make a huge difference. And during the COVID years, we had a big volcano eruption outside Reykjavik. It was close enough, but it was safe enough. And some people claim that the volcanic eruption actually saved Iceland from a second bankruptcy in this century. So here, volcanoes may have saved Iceland, and they also gave us a great opportunity to study volcanism in Iceland. And I'm scheduled to go back to Iceland in a few weeks, and most likely there will be another eruption soon. We expect many small eruptions over the next years. And now, unfortunately, we're close to infrastructure with the lavas, but in general, the eruptions have been rather benign. So this is very good. And there's all sorts of themes these days. It starts off with the more traditional national park theme, but then you can have a Kilauea military camp tour if you want. I haven't tried it, but I did try the volcano jeep safari in Indonesia. And then, so there is different nuances of volcano tourism. Here's just a few impressions. So there's the jeep safari I mentioned. And you can even surf down volcanic slopes if you're bold enough. So, but a few more words into history now. You may or may not know, this is Vesuvius volcano in Italy, and Vesuvius volcano was also a strange place, a strange form of volcano tourism, and that is Spartacus, the rebel. He actually had to find a hideout, and he decided there is a place the Romans will not easily go, and that is on top of the volcano. So he was hiding in between the valley between Soma and Vesuvius volcano, and indeed the Romans left him in peace for quite some time. They had a rather good spell up there, they were safe, but eventually, of course, Spartacus was defeated. In addition to that, eventually, Vesuvius erupted after Spartacus left, and then it covered Pompeii. So a lot of strange events there round about Vesuvius, and here's a few impressions. Here's an artist's impression of how the Vesuvius 79 AD eruption could have looked like. Well, of course, we don't know for sure, but it's not unreasonable to assume. And there, the negative sides, of course, are that the city was wiped out. The positive side is we learned an awful lot about Roman life. There, for example, is a little, well, kitchen, a street kitchen in the lower middle diagram. I always call it Roman McDonald's, and you could go in and buy some food on the quick. And yeah, a lot of information we are getting from such places, despite, of course, the initial catastrophe that is at the core of it. This brings me on to, well, beliefs, volcanoes and culture, as I call it. And, well, we can't have a talk like this without mentioning Pele, the goddess of volcanoes from Hawaii. And, well, it's said whenever she's angry, there will be an eruption. But it's also said that if you manage to get gin to her in time, she will calm down. So people throw gin into the craters. I'm not sure it really has an effect or a positive effect, but your belief may make a huge difference. So then here is White Island. This is the site of the disaster a few years ago where tourists got caught in an eruption. But it's also, in Maori tradition, the place where the sea devils live. And I guess many of these ancient legends, they are a bit like a simple form of a hazard catalogue. When people say sea devils live there, maybe it's not a safe place to go. I think that's the simple message. We have this in Europe, of course, as well. And here we have Hephaestus in Greek, or the god Vulcan in Roman. And it's the god of fire. He sits under Etna volcano, where he has a forge. And whenever he feels either particularly energetic or particularly angry, then he works the metal, and then, of course, we have eruptions at Etna and at Volcano and some of the other islands in the surrounding. This brings me back to Iceland. You may or may not have heard about the Edda that was written about 1,000 years ago, and it has different passages, but one of them describes the history of Iceland and events there. And people always ask, is there anything, well, that connects to the Nordic mythology? And indeed, there's a few very intriguing passages. There was a large eruption, the Eldgjá fires. We weren't entirely sure when exactly the eruption happened, but it must have been around about 930 AD. And there is some descriptions in the Edda that awfully sound like volcanic eruptions. So let me run through a few of those. So it says there will be a winter with the greatest frosts and keen winds, and the sun will do no good, and there will be 3 of these. And indeed, after the Eldgjá fissure eruption, there was 3 intense winters. The eruption was probably big enough to cause a little bit of a climate shift. And there it says in the Edda, the sun will turn black, and land will sink into the sea. The brightest stars will vanish from the skies. Fire will rage forth, and the flames will lick the heavens itself. And I like the next one. Boulders will slam together so big that trolls will tumble, and man will tread the path to hell. So this is what the Edda says, and well, it sounds awfully like a very bad volcanic eruption to me. And the Fimbul winter, the winter at the end of time, is likely inspired by volcanic eruptions. And just in addition to that, the whole thing seems to actually help us with the timing as well, because there's an independent source from the Saxon Chronicles, and they say that when their famous King Heinrich was about to die, the fires or the mountains of the north started to spew fire, implying that the king was so important that even the forces of nature would respond to his demise. So, having said all this, this is of course not a feature that's unique to Europe. We have these systems and beliefs all over the planet. Here in Indonesia, this is a newspaper clipping saying that villagers attempt to appease the volcano gods by offering a dance. Apparently it did not work, but you can try. And we have, of course, mythologies like this. In Mexico, this is Popocatépetl and Itztacuatl, and it's a rather sad story. And basically, one describes an angry warrior, Popocatépetl, and Itztacuatl is a lying, sleeping princess. And indeed, what it really messages us today is that Itztacuatl is a calm volcano. Popocatépetl is not. It's a very serious volcano. It's the angry one. So a few words about Japan as well. And here we have early drawings already going back hundreds of years. And here we see one of the earliest pieces where there's a drawing and a description. And this was the earliest stages of actually making cartoons. So volcanoes have been instrumental here. And this is Hokusai's work. There we have little bubbles, almost like little descriptive boxes, and volcanoes. That's his 52 versions of Fuji. And this concept still goes around, because if I walk down the street to my local sushi restaurant, they use the same symbology today. Having talked about religion, this is of course widespread in many forms in Europe. This is from Italy, and maybe a little bit more, well, less Christian, but many people believe that there are certain powers attached to stones. So here's a olivine-rich rock from a volcano, and there it says energies and success that come from volcanoes. So in how far this is true, well, we don't know, but of course belief makes a huge difference for individuals. This is again Vesuvius volcano, and not only has this inspired religious art in this case, Vesuvius also inspired art in general. I'll run you through a little time series now. So here is a drawing from 1684 with Vesuvius erupting. Here's one a little later, 1754, 1766, 1776, and this is yet later, 1787, and this actually happens to be the first recorded olive oil advertisement in the world. Now, not enough. Here we have one of the first photographs ever recorded, 1878, and this is also Vesuvius. So it's been inspiring art, and volcanoes have inspired not only paintings, but also, of course, literature. things, important works, like Jules Verne's Journey to the Center of the Earth. Well, he entered the Earth in Iceland and he resurfaced in Stromboli, implying there was a connection between volcanoes underground. Now, today, we can watch volcanoes in all sorts of movies, and this was one of the most inspirational movies for me. Krakatau, east of Java, is from the 1950s. I watched it as a 6-year-old on my parents' sofa. I was thrilled. I rewatched it a few years ago, and it didn't thrill me quite as much anymore. In addition, I realized that the title says Krakatoa, east of Java, and actually, Krakatoa is west of Java. So I'm not sure these movies are a lot better these days, Volcano and Dante's Peak, where here the Jeep is driving through freshly erupted lava. I don't think it works, but it comes with a volcano menu that you can buy, and therefore it offers a rounded experience, I guess. It's also implied in many music forms here. There's the band Krakatoa as a school band initially, and then later as a rock band. I haven't really listened to them, but people say it's not that great. And then here there's a radio station from New Jersey, and they have a volcano in their logo, and they are implying that, of course, they provide a volcanic experience. Just at the very end, and this is on request of my daughters, I have to show Vajana, as she's called in Sweden. I know there's different names in different countries, but this is all about Chakar, the lava monster, the monster that makes volcanic islands. And then once the lava monster comes down, the islands go green, they go fertile. And that's indeed what we see on Hawaii, but also in many parts of the Canaries. These islands, they erupt from fire, and once there's no eruption, vegetation takes hold. The islands technically erode, but that is also the time where we humans can come and live with them. So, in a quick summary, here's the important things I said today. There is a vast variety of resources, metals, gemstones. We mine sulfur, we use building materials, abrasion materials, we use geothermal power, we use it in food, drink production, as well as in cosmetics. And volcanoes had a huge impact on geotourism and culture. And I'd like you to just remember this a little bit next time you're using any of those products. Thank you very much.